Good evening, all of you.
Good evening, ma'am.
Good evening. Sai Kalyan, how are you? So today, after today's class, there are vacations for 2 weeks. Now I'll see you in June only. Okay, so since others have not come, while they are coming, we will do some questions. So today I plan to revise haloalkanes and haloarenes. I went through your answer papers and I realized there are some sections where you all are making mistake. Mainly it was in SN1 and SN2. So we will just revise those SN1, SN2 questions, and also we'll do a little bit more revision on optical isomerism, right? So by the time others come in, we will just do these questions. Now tell me, those who are present, now Sanjay, you should start. Can you match anything? Sanjay, Vaishnavi, Sai Kalyan has already.
Ma'am, fourth one goes with roots, ma'am. Fourth one goes with Woods-Fittig reaction.
Woods-Fittig reaction. Very good. First one goes with Woods-Fittig reaction. Very good. Right, then?
Ma'am, the
What about
fourth one
this?
is ma'am, fourth one is Finkelstein.
Fourth one is Finkelstein. Right, very good. Then, what about the second one?
Ma'am, is it Fittig reaction?
Yes, Fittig reaction. See, there are three reactions which are similar. Woods reaction, Fittig reaction, and Woods-Fittig reaction, right? So if it is, both here, you know, the alkyl halides, both of them, two molecules are there. So if both the molecules of alkyl halides are, you know, one molecule is alkyl halide and one is aryl halide, or haloalkane and haloarene. So this halogen is attached to the benzene ring. Here halogen is attached to R. Then it is Woods-Fittig. Okay. If both molecules, two molecules of aryl halide, that is chlorobenzene, so it is Fittig. And if there was a reaction where both were of alkyl halide, then it would have been Woods reaction. Okay. And the last one, obviously, now it has to be Sandmeyer's reaction. Right? This is benzene diazonium chloride, the salt which you obtain from aniline. And then when it reacts with cuprous chloride, you get Sandmeyer's reaction. Okay, so that is. Then, okay. Now let us do one more. Okay, tell me.
Ma'am, fourth one is C.
Fourth one is C. So one bromo, two methyl. Yes, fourth one. Butte.
First one is
First one is?
A.
First one is A. First one is A, 4-bromo pentuene. So this is 1, 2, 3, 4, 5. Right. So 4-bromo pentuene. Okay, this is correct. Then next one. Then 2 is which one? So again, start counting from the side which is nearest to the double bond, right? So this is 1, 2, 3, 4, 5. Right? So what is this one now? Two is this is also 1, 2, 3, 4, and 5, right? This answer is not there. Let me see the third one. 3.
Ma'am, it is also the same, ma'am.
Yeah. It is, there is some, I think I have made a mistake. I have copied it from that, exemplar problems. So 1, 2, 3, 4, and 5, right? So this is 4-bromo, 4-bromo bent, 4-bromo. So these answers, they are not matching. I'm sorry, leave this question, we will do it. There's some error here. Now do this one. Can you see it?
Yes, ma'am.
Yeah, now tell me. Column A and column B, you have to match. Can you understand or shall I explain? See, first one, chlorobenzene, the ortho, and Cl is coming in ortho and para position, right? What type of reaction is it? You have to tell me what type of reaction is it? All reactions of the benzene ring, they are what type
Ma'am,
of
is it
reaction?
addition?
Is it addition?
Reaction.
No. See, I have to explain this part to you. See, there are, all reactions of benzene ring. If I write it like this, you may not understand. But if I write C6H6 plus Cl2, right? Only one chlorine, supposing I add in presence of AlCl3. Instead of writing the benzene ring, I have written it like this. So what will you get? C6H5Cl plus HCl. C6H5Cl plus HCl, right? So if I write C6H5Cl plus HCl, can you make out one hydrogen has been replaced by one Cl? So first of all, it is not addition. Benzene is a very special case. Although there is a double bond, still addition does not take place. It is substitution. Right? And the type of substitution which is shown on at the benzene ring is always electrophilic substitution. Electrophilic substitution. Why does an electrophile always attack the benzene ring? Because benzene ring is rich in electrons and electrophiles are electron deficient. Okay. So all reactions of benzene are always, whenever a substituent is coming on the benzene ring, the reaction is always electrophilic substitution reaction. Sai Kalyan, you were saying something?
Actually, I was about to say first one is option A. I got confused.
Now, okay. So it is
Now I-
not, you
Now I-
understood? So it is electrophilic aromatic substitution. Then the second one here, you can see clearly H and Br are being added on propene, right? So what type of reaction it is? It has to be addition reaction, right? Here also there is a double bond. So electrophile is attracted to it first. So this becomes an addition, but it is a electrophilic addition. It's an electrophilic addition reaction. Now here what is happening? I is being replaced by OH. See here, instead of I, what is coming? OH is coming. So what is happening? Again, it is substitution. Something is replaced by something else, which is what? Substitution. What type of substitution it is? It is a negative species which is being replaced. Okay, it is a negative species which is being replaced. So what type of substitution it will be then? It will be nucleophilic substitution. Okay, nucleophilic substitution. This one. Now, next one, what is happening? This one. This is also nucleophilic substitution here, but since it is happening with the benzene ring, it is nucleophilic aromatic substitution. And the last one, what is happening? Saturated compound, it has to be elimination. And in elimination, I have told you the rule, it is Setzeff's rule. Setzeff's rule, what does the Setzeff's rule say? That the hydrogen will be always eliminated from that carbon which has less number of hydrogen atoms. So here, hydrogen is not eliminated from this carbon, it is eliminated from this. So you will get 2-butene as. So I want to actually, yeah, tell me.
Ma'am, option 3 also, it's a benzene right now.
Yeah, option 3 is benzene, but nothing is being added on the benzene ring, no? Benzene ring is as it is. Okay, this outside thing is changing. Cl is being replaced by OH. So outside thing is changing. That is why it is a substitution. You have already nucleophilic substitution, and since it is outside the benzene ring, we call it aromatic substitution. Okay. So I can now, we can just go through different types of reactions which each class of compound undergoes. You should know what are all the type of reactions which alkyl halides or haloalkanes and haloarenes can undergo. So haloalkanes, they always, haloalkanes means where benzene, there is no benzene ring, only an open chain compound. So if it is haloalkane, then it will undergo what type of reaction? It undergoes substitution nucleophilic, substitution. And what type of substitution? Nucleophilic. Right? And here it can be of two types. I have told you SN1 and SN2. So in haloalkanes, it is always a substitution reaction and it is either SN1 or it is SN2. Right? SN1, if your haloalkane has tertiary alkyl halide. If it is tertiary, then SN1. If it is primary, then SN2. Okay, but haloalkanes will undergo substitution reaction, right? They can undergo substitution reaction either SN1 or SN2. Then haloarenes. Haloarenes will undergo which type of reaction? Haloarenes will undergo always substitution reaction. Two types of reaction they can undergo. Substitution, and it can be either nucleophilic or electrophilic. Right? So if along with alkyl halide there is a benzene ring, then it can be nucleophilic or electrophilic. So if the halogen atom is being replaced, then it is nucleophilic. Cl is being replaced by something else. Cl is replaced by a nucleophile. Then it is nucleophilic substitution. But on the benzene ring, if some hydrogen of the benzene ring, hydrogen of the benzene ring is being replaced. Okay, so something is getting attached to the benzene ring, hydrogen of benzene ring is replaced, right? Then it is electrophilic substitution. Okay, so remember, you can in haloalkanes, properties of haloalkanes reactions will be substitution. And what type of substitution? Nucleophilic. If it is haloarenes, what type of reaction? Substitution. It can be nucleophilic or it can be electrophilic. Okay. Now, there's one more type of reactions that you see here in preparation of alkyl halides. Okay, in preparation of alkyl halides, you will come across two other type of reaction. That is why this chapter is very, very important, because all types of reactions you see. Now, in preparation of alkyl halides, you can see addition reaction. Okay, where do you see addition? Alkenes to alkyl halides by addition of HBr or HCl. Okay, so that is addition reaction. This addition reaction is always electrophilic addition. Electrophilic addition, right? The second type of reaction which you see in preparation, that is elimination reaction. Okay, elimination reaction. When we do elimination reaction, what are we doing? We are taking an, no, this is not for preparation of alkyl halide. This is, yeah, preparation of elimination we come across, yeah, when a single type of elimination reaction where from alkyl halide, it is not in preparation. It is alkyl halide to alkene. When you have to prepare alkyl halide to alkene, then it is an elimination reaction. So you have to learn it like this. Elimination reaction can also be there. So you can see addition, you can see substitution, you can see elimination. All types of reactions can be seen in alkyl halide. So you should be able to identify a reaction of alkyl halide. Now I'll give you a few reactions and you should be able to identify. So supposing it is CH3, CH2, Cl plus NaCN, giving CH3, CH2, Cn plus NaCl. What type of reaction is it? Tell me.
Substitution.
It is substitution. Very good. It is substitution. What type of substitution? Electrophilic or nucleophilic?
Nucleophilic.
Nucleophilic substitution. Okay, I told you alkyl halides will undergo nucleophilic substitution. What is a nucleophile? Nucleophile is a negative thing. So the negative part of one is being replaced by the other one. This Cl is being replaced by Cn. So it is nucleophilic substitution. Now the other reaction is, this is the benzene ring, chlorobenzene. And I reacted with chlorine in presence of AlCl3, right? I will get, or rather I will, instead of chlorine, I will take CH3Cl, right? I will get, the Cl is not affected, Cl is as it is, but I put a CH3 here and HCl. What type of reaction is this? Tell me, what type of reaction is this? Here also, what type of reaction is happening? Is it addition or is it substitution? First, tell me, is it addition or substitution? Vaishnavi?
Is it addition?
Why do you think it is addition, Vaishnavi? You are getting stuck with the wrong thing. I explained. Why do you tell me? Why do you think it is addition? Because you think
First,
that CH3 is added here. Because of that.
oh, okay, ma'am. It's substitution because one hydrogen is removed and CH3 is added instead of
Yes. Yeah.
that.
So
Okay. Yes,
whenever
ma'am,
it
it's
is
substitution.
substitution, and when it is a benzene ring, it is always electrophilic substitution. Why? Because H is removed as H plus and CH3 comes in as CH3 plus. So it is electrophilic substitution, right? Now the next one. Supposing I have the benzene ring and Cl and I reacted with NaOH, right? High temperature and pressure. Then Cl is replaced by OH. What type of reaction is this? What type of reaction is this? Who will tell me? Hariharan, tell me.
Ma'am,
Hariharan, please tell me. What happened, Hariharan? What is happening? Is something being? Yes, tell me.
substitution.
Yeah, it is substitution. Very good.
Cl with the OH, ma'am.
Yeah, substitution. Very good. It is substitution. And what type of substitution?
Electrophilic.
What is the charge on OH? Tell me.
Negative, ma'am.
Negative. So if it is negative, what will be the type of what is negative is being replaced by negative. So it will be what?
Nucleophilic.
It will be nucleophilic. Okay. You should know what is an electrophile and nucleophile. You should not confuse between these two. What is electrophile and what is nucleophile? Right? Electrophile is what? Electrophile is electron-loving species. Electron-loving. Right? To file means to love. So electron-loving. Electron-loving means if it is electron-loving, that means it loves negative charge. If something loves negative charge, then what should be the charge on that? It will be positive. So species which have a positive charge, like for example, H plus, CH3 plus, Br plus, these are all electrophiles, right? And where will they attack? Where are they attracted, or where will they attack the reagent or the compound with which they are reacting? Where will they attack? They will attack it at a place where there are electrons. So wherever there is a double bond, these electrophiles are attracted towards a double bond because in double bond there are electrons available freely. So that type of reaction where electrophile attacks, it becomes electrophilic. Nucleophilic means what? Nucleus loving. What is the charge in the nucleus? Tell me. The charge on the nucleus is positive. So the nucleophile is negatively charged species like OH minus, Cl minus, right? Anything which is minus, that is a nucleophile. So anything which is negatively charged is a nucleophile. Things which are positively charged, which can accept a pair of electrons, they are known as electron loving or They are electrophiles. So if a reaction is taking place where one electrophile is being replaced by another one that is known as electrophilic. When one nucleophile is being replaced by another one, then it is nucleophilic substitution. Okay, so you have to just practice and learn that. Okay, now the third type of reaction, I want to give you one example. So supposing it is CH3, CH double bond CH2. This comes in preparation of alkyl halides. So I want to add HCl. I will get CH3, CHCl, CH3. Now, can you tell me what type of reaction is this? Who will tell me what type of reaction? First of all,
Ma'am, it's
tell me.
addition.
It is addition. Very good. It is addition reaction, right? Now, what adds on it first? The reagent. If the reagent which adds first is an electrophile, then we call it electrophilic. If it is a nucleophile, then we'll call it nucleophilic. But electrophile always attacks first because of a double bond. So what type of addition will it become? Electrophilic addition. Okay, it becomes electrophilic addition, right? So these are things which you please in these 14 days of holidays, please revise basics of organic chemistry from the textbook. You must understand what is different type of reaction. Okay, so this is addition reaction. How do we identify addition reaction? When an unsaturated compound gives you a saturated product, like a compound which has a double bond or a triple bond. After the reaction, no double bond or triple bond in the compound. So unsaturated has changed into saturated. Then it is addition reaction. Addition, electrophilic here, in this case, electrophilic addition. Now the last type of reaction for which alkyl halides we know, like for example, if I have an alkyl halide, now I have CH3Cl and this one, 2-chloropropane, and I reacted with alcoholic KOH. You remember what alcoholic KOH does? It replaces, it brings about elimination, dehydrohalogenation, the Cl and H from the adjacent carbon atom. So what will you get? CH3, CH double bond CH2. So by this method, what do? You convert an alkyl halide into an alkene. Now what is happening? A saturated compound is changing into unsaturated. So when saturated changes into unsaturated, then it is a elimination reaction. So this is an example of which type of reaction? Elimination. In case of elimination, it is not necessary to write electrophilic or nucleophilic. Elimination. So there are three types of reactions you have to identify. First, addition, then substitution, and then elimination. So in addition, you should be able to identify, in substitution, you should be able to identify whether it is nucleophilic or electrophilic. And the addition reactions that you have learned, they are all, so far, they are all electrophilic. When we learn aldehydes and ketones, we will learn the other type. So right now we have learned 5 types of reactions, 2 types of substitution reactions, then 1 type of addition reaction and 1 type of elimination, right? So you have to revise and learn and identify those different types of reactions, okay? Now let us do one more question. So, okay. Now match the following again. Now Hari Raghav and Hari Haran, you should take part in this because you were not there in the beginning. Okay, so Hari Raghav, tell me. How will you match? Elimination of HX from alkyl halide. Which rule follows? Which one of them you can? I explained. The last thing we did was elimination. And elimination, remember, elimination reaction here, it follows Sedgwick's rule. Okay, what is the Sedgwick's rule? If you remember, when I taught you, I told you it is poor becomes poorer. Right? So, in an elimination reaction of alkyl halides giving alkenes, right? What is the way to remember this? Supposing I have this compound and I react it with alcoholic KOH, right? What will happen? Br will be replaced along with hydrogen. Where will the hydrogen go from? It will go from either this carbon or this carbon, adjacent carbon. So it will always go from that carbon which has less number of hydrogen atoms, and it will give you an unsaturated compound 2-butene. Okay, so that is how you have to remember. So now if you look at this, can you connect it? Any one of them. Now this is all for revision. All of you are quiet. It's not a revision for me. It is a revision for you. Come on, somebody
Ma'am.
tell me. Yeah.
For chemicals in fire extinguisher, it is chlorobromocarbons.
Yeah. Chemicals for fire extinguisher, they are fluorochlorocarbon.
Ma'am, for
Fluorobromocarbon.
SN1 reaction, it is racemization.
Yes. So let me get a black. So chemicals in fire extinguisher, it is fluorochromocarbons.
Elimination of
And-
HX from aldehydes is
What is it? Tell me, elimination of HX from alkyl halide. What is that?
It's Sedgwick rule.
Yeah, it is Sedgwick's rule. Right. And SN1
And
is
SN1 reaction
racemization.
is
SN1 is racemization. Then
aldehyde behave.
alkylidine
This-
halides, right? Alkylidine are geminal.
Ma'am, domination of alkenes, vicinal type bromides.
Lithium
Yeah.
dibromides.
Did you understand? Now this thing I have mentioned, but probably you are not recalling. See, supposing I have CH3CHCl2, right? So this compound, they are what are they? Geminal dihalides, right? And what is the name of this compound? It is IUPAC name is 1,1-dichloroethane, but a common name is ethylidene dichloride. Okay, ethylidene dichloride. If you have any difficulty in remembering racemization, then we will discuss a little bit about here. I will discuss a little bit about optical isomerism. Okay, so what are the important things about optical isomers that you need to know? First, very important thing about optical isomers is that it is shown by compounds which have asymmetric carbon atom. Okay, asymmetric carbon atom. Right now, when is the carbon atom asymmetric? It is asymmetric when it has 4 different groups around it. 4 different groups around it. Okay, so if a carbon atom has 4 different groups around it, then it is asymmetric. Say, for example, if I have H here, and I have OH here, and I have CH3 here, and I have COOH here. This carbon atom on which I am drawing a star, this carbon atom is asymmetric, right? This is an asymmetric carbon atom. And if I take another one, here I write H, here I write OH, here CH3, and here COOH, right? Now what have I done? This line shows I am drawing a mirror image, okay? So if I draw a mirror image, then what is happening? That these two, they are isomers, right? Now, if I take any compound, compound and draw a molecule which is mirror image, that will not be optical isomer. For a compound to be optical isomer, or for a compound so that to be such that its mirror image is optical isomer, it is important that the carbon should be asymmetric. That means it should be attached to 4 different groups around it. So this compound has a asymmetric carbon atom. It has 4 different groups around it. So its mirror image is an isomer, right? So this isomer and this isomer, they have difference in orientation in space, because of which their one property is different. What is a property which is different? The only one property which is different is they deflect the plane polarized light at different angles. Like one deflects the plane polarized light to the left and the other to the right. So one of them is called dextro and the other one is called levo, right? So the one which deflects the plane of polarized light to the left is called dextro, and the one which reflects the plane of polarized light to the right is called levo. Okay. Actually, I can show you one video where which is about optical isomerism. Just I'll share just 1 minute.
Ma'am, I have a doubt.
Yeah, tell me.
Ma'am, if a carbon compound is said to be symmetric, if all the atoms attached to the carbon, main carbon is different and it is the same, it is asymmetric.
If all the atoms attached to the main carbon atom are different, then it is asymmetric. Otherwise, it is symmetric. Asymmetric means no symmetry. No symmetry. Opposite of symmetry is asymmetric. Okay. General chemistry, isomerism. Just 1 minute, I isomerism. Now, this is one PPT which I want to show you so that all the doubts that you have regarding isomerism should be cleared. Slide show. Okay, so what is it? What is this? What is the importance of molecules or objects which are asymmetric? So everything can have a mirror image. Okay, all objects will have a mirror image. So if I take an object like O, I want to just generally explain. So this is a mirror and I take a object which is O. Now O is absolutely symmetrical. So if its mirror image will be completely, if I pick this O and place it on that, the mirror image will be completely superimposable, right? So that means this O and this O, they are similar. There is no change. But if I take R, then the mirror image will be like this, right? So the mirror image will be non-superimposable. So how will, like for example, my hands. So the two hands, they are mirror images of each other, right? But these mirror images are non-superimposable. What is the meaning of non-superimposable? That if I take and place this hand over the other one like this, then both the thumbs will come together, but this side and this side, they will change. So the mirror images are different from each other. Okay, so that is what is non-superimposable mirror image. Now, in case of molecules, how will you understand that there is the molecule which is the mirror image is non-superimposable? It is only when the carbon atom is attached to 4 different groups. Now, this carbon atom here is attached to 1 and 2 and 3 and 4 different groups. So its mirror image will be another molecule, and that will have different properties. This molecule and this molecule, they have similar groups attached to it, but their orientation in space is different. And so the molecules are different. Now so this is how it is, right? So this carbon atom here is chiral carbon. Chiral is same as asymmetric. Asymmetric. Right? Chiral carbon is a carbon which is attached to 4 different groups. Okay. Then what is the thing which they change? Okay, so the only property which is different in all these compounds is that they deflect the plane of polarized light. Now, first you should understand what is plane polarized light. So the light, it is different wave, first white light, if you take monochromatic light means only one frequency, but there is in all directions like this and like this. So you have only a light of single frequency and single wave, in one direction. Okay, only all in one direction. Then it is a plane polarized light. Now what you do, so this source of light, this is unpolarized light and this is plane polarized light. Now there is a small animation if you see this one. See here, this is a monochromatic light. Now it is trying to go through this first slit, right? This is a sort of polarimeter. This is how the polarimeter works, right? So one slit. Now this, as it passes, now this plane polarized light cannot pass through the second slit. Why? Because it is not aligned. So what happens is, let me take another slide. Now this is how you measure in polarimeter. So you have a substance. This sample tube contains an optically active substance, right? Now when it passes through, this direction of the light changes, right? And when it changes, you can see here, when it passes through the analyzer and you can see the light has changed and got deflected. Now, when it comes out here, right? So it has deflected the plane of polarized light. Initially, the light was like this. Now it has got deflected by an angle. If it has got deflected to the right, then the substance in the sample tube was dextro-rotatory, dextro. And if it gets deflected to the left, it is levo-rotatory. So what is the difference between, so these two compounds, one which deflected to the right and the other one which deflected it to the left, they are optical isomers. They are optical isomers. So what is the significance of this in so what is the significance of this? Sorry. Sorry, the screen is loading. Yes. So what is the significance of it while we are learning alkyl halides? So for learning alkyl halides, please see here. Children, can you see the screen? Vaishnavi, can you see the screen? Hello?
Yes, ma'am.
So which screen are you able to see? Are you able to see the optical isomer screen? Are
Yes,
you able to
ma'am.
see the black screen? Yeah. So the importance of this one is, I don't know why it is not.
And we can't see the screen.
Now you can't, I have cancelled it, but somehow I am not one participant can. Now it's okay. Now it should work. Okay, so why haloalkanes it becomes important in case of haloalkanes is that supposing I have an alkyl halide like this, you know, I will show 4 different groups around it. So supposing I have an alkyl halide which has A and B and D, and here I have Cl. Then this carbon atom here is what? It is asymmetric, right? Now, when this takes part in a reaction, and if the reaction is SN1, in SN1, what happens? The reaction happens in 2 steps. First, this will break down, and it will break down and give me what? It will give C plus, A here, B here, and D here, plus Cl minus. Right? Now this intermediate will be formed. Now when this intermediate is formed, then what happens? If I am having a reaction with OH minus, NaOH. Now OH can attach from 2 sides. It can attach from here or it can attach from there. So if OH attaches from 2 sides, what is the 2 products I will get? I will get C, A, B, D and OH here. The other case will be I'll get C, OH here, A, B, and D. Can you see? They are mirror images of each other. So 50% chances of getting D isomer, and there is a 50% chance of getting a L isomer. 50% D and 50% L isomer I will get. So if you understood something of the picture that I showed you of a polarimeter, what will happen in the sample tube if I put 50% D and 50% L isomer, then what will happen? Some molecules will deflect the plane polarized light to the left and some will deflect it to the right. So what will happen by the time you see the light in the analyzer, there'll be no deflection. So this mixture of 50% D and 50% L isomer, it is known as DL mixture. DL mixture, and DL mixture is also called racemic mixture. And racemic mixture is optically inactive. Optically inactive are those which do not deflect the plane of polarized light in the optic polarimeter. Why it is not deflecting? Because it is 50% D and 50% L. So when I do the nucleophilic substitution SN1 type, which occurs in 2 steps. In the first step, the carbocation is formed, and the carbocation, once it is formed, it has the ability to attract Cl from both directions. So you can get D isomer as well as L isomer, and so you will get a DL mixture. So all those compounds which have can undergo SN1 reaction, they will get racemized after the reaction. They will undergo racemization. So you only have to see which compounds will undergo SN1 reaction. So which will undergo SN1 reaction? Generally those which are tertiary alkyl halides. Okay, which can form a stable carbocation, they will. Now supposing my compound is undergoing SN2 reaction, then what will happen? So supposing I have this carbon, here it is A, here it is B, here it is D, and here it is Cl. Similar compound, but this is a primary alkyl halide. Supposing it is a primary alkyl halide, then what happens? The reaction occurs in a single step, not in 2 steps. So in this reaction, what will happen? A, B, and D here. Now C is slowly breaking out. It doesn't break out quickly, but OH minus comes from the other side. So OH will always, so supposing this was D isomer, then what will the product be? The product will be the opposite. So here the Cl was on the right side. The OH will always be on the left. So A, B, and D. It will get inverted. So if it is D, then this will be L isomer, right? So there will be optical inversion. So optical inversion takes place when my reaction is SN2. If my reaction is SN1, then there will be racemization. So this is what you have to learn when you are doing alkyl halides, because you have to understand the mechanism of SN1 and SN2, that is in your syllabus. So in SN1 reaction occurs in, we have learned it, SN1 reaction occurs in 2 steps. In SN2, the reaction occurs in 1 step. See, the 2 here says it is a bimolecular reaction. Bimolecular reaction means in the rate determining step, or there are 2 molecules taking part in the reaction simultaneously. That is the alkyl halide and the reagent, both are participating. But the first one is called unimolecular because of reaction occurs in 2 steps. 1 step is a slow step, and in that slow step, only 1 molecule of alkyl halide participates, right? So the rate of reaction depends on only the concentration of alkyl halide. That is why you call it SN1, and this one is called SN2. So in this part of haloalkenes and haloarenes, it is all about, which will undergo SN1, which will undergo SN2. So you have to understand this section clearly. There are a lot of questions which are asked from here. So we'll practice a little more. So I wanted to revise it because in your papers, I found these are the things which you had not answered correctly. Now this one, again, tell me what is the answer for this? What, all of you, please look carefully and let me see who gives me the correct answer. What is A in the following reaction? So what is happening? First of all, what type of reaction is happening here? Is it a substitution reaction or is it an elimination reaction? What should happen first? What will HCl do?
Ma'am, it will be addition.
Very good. It will be addition reaction. Now, what will be the product? You have to remember the Marconi-Coffs rule. Remember quickly. Where will the Cl come? C addition.
CH bond, ma'am.
Yeah, so it will come here and hydrogen will come here. So which is the correct answer?
Option C, ma'am.
Yes, very good. Okay, so why first thing you identified was addition will take place because HCl for nothing will happen to the benzene ring because the reagent is only HCl. For something to come on the benzene ring, supposing I wanted Cl to come on the benzene ring, then what reagent I should have used? I should have used Cl2 and AlCl3, right? Only when there is Cl2 and AlCl3, Cl will become Cl plus. So then we would have got this product. But we don't have chlorine and anhydrous aluminum chloride. So we are having HCl, direct addition on this bond. Okay. Then yes, quickly tell me. Which of the
Option 1,
following
ma'am. Ethylene chloride.
Yeah, these are multiple, those types of MCQs where more than one possible answer. Okay, so what did you say?
1, ma'am. First option.
First one is there, definitely. Then
Ma'am, option 2.
Okay, just think. What is the difference between 1 and 2? Are they the same?
No, sorry, ma'am, not 1 and 2. I missaid the ethylene as ethyl sorry, not option 2.
Okay.
3.
3 is the correct. Right? Methylene chloride is CH2, Cl2. Ethylidene dichloride is CH3, CHCl2. Ethylene dichloride is CH2Cl and CH2Cl. Ethylene dichloride. This is ethylene. Sorry, no 2 hydrogen. This is. Okay, this is ethylene dichloride. And benzyl chloride obviously has only 1 chlorine, so it is not geminal. So 1 and 3. Now 40, which of the following are secondary bromides?
Ma'am, 3.
Yes, 3 is correct. And one more is there.
4.
You should be able to write them in the expanded form, Vaishnavi, right? So what is, when I write 2 CH3 here and carbon after this, what does it mean? This carbon is attached to 2 CH3, right? And here there is a Br. And then here CH2 and here CH3, right? So fourth cannot be because this carbon is attached to 3 other carbon atoms. I have to look at that one, which is secondary bromide. That means my
The
yeah,
first one, ma'am.
yes, it is the first one. So in the first one, it is C, CH3, CH3, H, and here Br. Okay, so this carbon here is the secondary carbon. So it is 1 and then 41. Which of the following compounds can be classified as aryl halides? Aryl halides are which ones where Cl is directly attached to the benzene ring. Where Cl is directly attached to the benzene ring. Now let us see. This is whenever there is a P, it could be a aryl halide. So let us see here. You should be able to write the actual structure. So here there is a C6H4, so there is a benzene ring, right? And on the benzene ring, on one carbon, there is one place, there is a Cl. And on this, another place, this one, it is CH2, CH, CH3, and CH3. This is the first compound. Since chlorine is already attached to the benzene ring, it is 1, right? Then this one is clearly an alkyl halide, C6H5Cl. Now, what about this one? Now, let us see the structure of this one, second one. So, for the second one, if you see carefully, you know, these are complicated ways of writing simple compounds, but because they want to write it in a straight line, that is why I thought you should practice this. So here also there is C6H4. So that means there is a benzene ring. When it is C6H6, this is C6H6. The moment I put something on the benzene ring, it is always in place of hydrogen. So on para position, there is a on para position, there is a CH. First, there is a CH2, CH3. So here there is a CH2, CH3. So C6H5, CH2, CH3. Now there is one more group here. Now this is CHCl and here this is CH. So the Cl is not directly attached to the benzene ring, it is attached to the carbon side chain. So this is also not an alkyl halide. So alkyl halides are only 2, 1 and 4. Okay, so such questions also can be asked, so you should be familiar with them. Then the next one is, this also I want you to do because this is based on what we were learning just now. If you have understood, then you will be able to answer. It'll take a little time, think and tell me. So this is, you know, if you see like this sort of molecule is written, that means, you know, they are trying to show the 3D picture of the molecule. The solid line is the line which is showing the molecule coming above the paper. And the dotted line is a molecule which is the part of the bond going below the paper. Okay, so this is how you sometimes draw it. This is a Fisher projection. Now see, on the basis of this reaction, which of the following statements are correct about the mechanism of this reaction? Now, if you can see in the reaction, it is very clear. What is clear? That Cl is leaving and OH is adding. Okay.
This option 2, ma'am. Option 2, 35th.
Also, remember that these are, you can have more than one options for this. Okay, these are those MCQs where you have more than one option. Okay, now you are saying option 2. OH will attach to the substrate B. Now here you should understand what is OH. OH is a nucleophile. right? And substrate is this molecule B. This is a substrate, right? And this is a product. And what remains, comes out, is also a nucleophile. Now, Sai Krishnan, Sai Kalyan, see what you said, option 2. So OH will attach to the substrate from one side, and Cl will simultaneously move simultaneously leave from the other side. Okay, now here, can you see this molecule and this molecule? Can you see carefully? The OHCl has gone from this side, and OH has also come on the same side. It has not come on the back side. Has it changed? This rest of the molecule position of bonds has not changed at all. So 2 is not the option. Now think of the remaining. 2 is not the option. Now look at the first one. A carbocation is formed as an intermediate in this reaction. Obviously, if the Cl is coming on the same side, then the intermediate should have been a carbocation. So 1 is the correct option. Now let us look at the third one. An unstable intermediate is formed in which OH and Cl will be attached by weak bonds. This is also not the correct option, right? That happens when, if 2 was correct, then 3 would have been correct. But since it is not 2, it cannot be 3. So the type of reaction is SN1. So this cannot be. Reaction proceeds through SN1 mechanism. So it is this. So 1 and 4 are the correct options. Did all of you understand? See, if I had shown the product having CH3 and C and H here and C2H5 here, and OH on this side, on the left side, then it should have been SN2. And then 2 and 3 would have been the correct answer. But Cl is attaching on the same side, OH is attaching on the same side as Cl. So it cannot be SN2, so it is SN1. Now the next one is, which of the following statements are correct about the kinetics of this reaction? Okay, the rate of reaction depends only on the concentration of B. No, it depends. SN1 reaction, what did I tell you? It depends only on the concentration of the alkyl halide. So it does not depend on both. It depends on only on concentration of alkyl halide. Then molecularity of the reaction is 1. This is true because we call it SN1. So only 1 is correct. This is also wrong. So only 1. Okay. So SN1 type of reaction. This is showing a SN1 type of reaction. Now this was another question where many of you got it wrong in the test. So that's why I have taken it up. Which is the correct increasing order of boiling points of the following compounds? Here only one answer. Okay, so you don't, obviously there cannot be 2.
Ma'am, for 31st, this option 2, ma'am.
Increasing of order of following compounds. Boiling point. So
31st.
31st is to some extent you are right. Second one up to here, it is correct. Right? This is correct. Right?
Option 2, ma'am.
But the bromobenzene will have the highest boiling point. Okay, so the number of carbon atoms increase, the intermolecular force of attraction increases. So 1 bromobethane, then 2 bromopropane, then you can see here there are 2, here there are 3, here there are 4, and here there are 6. So As the number of carbon atoms increase, the boiling point increases. So answer is 4. Okay. Now here, look at the 30th one. In 30th one, you have to see actually, see the difference in 30th and 31st is, in the 31st, it is always the halogen is the same, that is bromo, bromo, bromo. But here the halogen, the base compound is same, all of them have butane, right? So the carbon chain is not having any effect, but it is the atom which is attached to that. So larger the atom, higher the boiling point. So iodobutane will have the highest. So first one, so answer is the first one, right? So among alkanes, if you are looking at different alkyl halides, if the alkyl halides have same base alkane, that is all of them are butane, then you decide based on the size of the halogen. So if the halogen which is largest in size will make highest boiling point. So iodine is the largest size in the periodic table. If you remember, among halogens, iodine is at the bottom. So it has the largest size, and so its boiling point is highest. And here, if the halogen is same and the base compound, base alkane is changing, then you look at the number of carbon atoms. Larger the number of carbon atoms, greater the boiling. Okay, that is. Now, in the questions 26 to 29, arrange the compounds in increasing order of rate of reaction towards nucleophilic substitution. Now, this is also one question which I wanted to explain a little more. So let me explain. So before you start answering, I want to explain a few things. So what I want to tell you is, this is, see, this is your benzene ring. Okay. On the benzene ring, I have put chlorine. Now, if I put any substituent on the benzene ring, okay, somebody is trying to draw here. So, somebody else is drawing. I don't know who. Yeah. So here what happens is that if I take the chlorobenzene and I put a substituent on it like NO2, right? Now NO2 is considered as electron withdrawing group, electron withdrawing group. Okay, it withdraws electrons by minus M effect. So it is electron withdrawing, right? So if I put NO2 on the benzene ring, then this bond, this carbon bond here, this becomes weak. So electron withdrawing groups, they weaken the carbon chlorine bond. Instead of this, if I put a CH3 on the benzene ring, it is called electron pumping group. Electron pumping group. Okay, sometimes we call it, this one is called EWG and this is called EPG. Okay, so electron withdrawing groups, they increase the rate of nucleophilic substitution reaction. Substitution reaction is which one? Where Cl will be replaced by something else. So if on the benzene ring you have a group which is EWG, then the rate of electrophilic substitution reaction will be increased. Why? Because this bond will break easily. Okay. Now if there is an electron pumping group, right, then it is opposite effect. So now that is part one. Then the other thing is that the effect of nitro group, NO2 group, is maximum when it is on ortho and para position. So if I have nitro group here, it will be very effective. If I have nitro group on, or because Cl is orthopara directing, if I have NO2 here, it will be very effective. But if I have NO2 on the meta position, then it will not be so effective. Okay, so based on this, you have to do these questions. Okay, so we have to arrange the compound in increasing order of rate of reaction towards nucleophilic substitution. Okay, so which will show maximum rate of nucleophilic substitution? 20.
Miss,
Yeah,
for 26, I don't know the right answer, but is it option 3?
yes, it is option 3. Very good. So it is option 3. Why?
And,
Because, yeah, so now did you get the hang of it? So if NO2 group is on meta position, it will not be effective. It will increase the rate of reaction, but maximum rate of reaction will be increased when NO2 is on ortho position. So this is one maximum, then this is next, and the least rate of reaction will be A, so option is C. Now 27, what will be the option? Now this is having reverse effect on rate of reaction because CH3 is EPG group. It decreases the rate of reaction. So obviously, chlorobenzene should have highest rate of reaction.
option 4.
Yes, option 4. Okay, A will have the highest rate of reaction. And then C, because CH3 will not have so much effect when it is on meta position, and it will have effect more when it, so this will be the least, and then this, and then this. Okay, very good. Sai Kalyan, you have got it. Have all others understood this? Now for 28, if the number of one NO2 group can increase the rate of reaction, then what will be the effect of 3 NO2 groups? It will even increase the rate of reaction further. So maximum rate of reaction will be C, right? There's only one option with C. So 28 is 4. Did you understand, all of you? Vaishnavi, Hari Haran, Hari
Yes, ma'am.
Raghav, did you all understand? I can't see, I think Sanjay has already left. Okay. Now let us do one more. Okay, which of the following compounds will give a racemic mixture on nucleophilic substitution by OH? Okay, which of the compounds? So first you have to see which is a primary alkyl halide, which is a secondary alkyl halide, which is a tertiary alkyl halide, because which one will give racemic mixture? Vaishnavi, which one will give racemic mixture? The one which undergoes reaction by SN1 or SN2? Vaishnavi, are you there?
Ma'am, is
Yeah.
it SN1?
Yes, it is SN1, right? So SN1 will always give racemic mixture. Which compound shows SN1 reaction? The tertiary. Okay, anything which will undergo tertiary, which has a tertiary carbon will undergo SN1 first of all. So which one has a tertiary carbon? Tell me in this.
Option B.
B. B has a tertiary carbon. So this is definitely one which will give racemic mixture. Then along with B, there has to be one because there is only B option is not here. So look at another one.
Is it A,
B
ma'am?
along with A is secondary. So A can also, this is primary, so this will not undergo, but there is steric hindrance here. Just 1 minute, I'll check the answer. Just think, all of you. This is (26), 25. Question. And this is from that, I told you, 25 is. Which one
Ma'am.
we were?
Ma'am, is the final answer option 4?
Why do you think A and C?
Ma'am, because normally race fixation occurs on mixture of two enantiomers. Enantiomers are possess non-simple principal mirror images and they are chiral carbons. Ma'am. So B is
Okay,
not.
that is very, very important. This has a chiral carbon. This
B is
carbon,
ma'am.
this is a chiral carbon, right? B is not chiral. So even though, so actually all of them can we should not look at which one will undergo SN1. Definitely it should undergo SN1, but in addition to that, we should also look at the molecule which should be chiral. So here A is chiral, and this one C also, no, but C where the Br is attached is not a chiral carbon. So it has to be A. You are right, it has to be A. Secondary, so it can undergo racemization, and it is a chiral carbon. This carbon is chiral. Okay, Vaishnavi, why will this not undergo racemization? It will not, even if it undergoes racemization, your product is not optically active, right? What will be the product? Your product will be CH3, C, CH3, and C2H5 and OH. So 2CH3. So the product is not optically active. So the question of racemization does not arise. The question of racemization arises if your product is likely to be optically active. Here also, your Br will be replaced by OH, so the product will be optically. Only here your product is likely to be optically active. So what will be the product in case of A? It will be CH3, CH, OH, and C2H5. And this can have both options. And since it is secondary, it can undergo a SN1 reaction. And so the product formed will be racemized. So answer is 1, and that is A. Okay, very good point, cycle.
It's MSc also, no, ma'am. They haven't asked which will give the highest reactivity to react it like that. They asked which will give racemic mixture. C, yes, it is compared to A, it is less reactive, but C will also give the racemic mixture, no, ma'am, because it is a chiral carbon.
C can also give a racemic mixture, yes, because it is a chiral carbon. Because
But
this
C,
here there is a chiral carbon. This carbon is chiral, right? You are. So C can also give, because after Br, right now also this carbon is chiral, and when Br is replaced also it will remain chiral. So since there is a chiral carbon, there is a possibility of racemization. Yes, the amount of the possibility of racemization may be less, but here again, you know, there's another thing. There is a possibility of SN1 reaction only because of this large molecule, the back attack is not possible. So it will only undergo, even though it is a primary alkyl halide. So that is also a good point. So A and C can be, so A and C is there, yes. So 4 is a possible answer. Okay, I will give it to 4. Good, very good. Good point, Sai Kalyan. You have understood it very well. Vaishnavi, you were saying something.
No, ma'am, I understand.
Okay. Now do this one. Which of the carbon atoms present in the molecule given below are asymmetric? Tell me. Which carbon atoms have 4 different groups around them? Quickly. Hariharan, can you tell me? Hariharan? Is he there? Yeah. I was not looking at, I am going by backwards. 24. Can you tell me which are the asymmetric carbon atoms in 24? Hariharan, can you tell me? What is the answer? See, look at A. Is it asymmetric? It cannot be because there are only 3 groups around it. There should
Symmetric.
be 4. So we cannot look at A. Now B. B is asymmetric because on one side there is the COH, OH, H and this one. So B is asymmetric. C is also asymmetric and D is not asymmetric. So B and C. So answer is 2. Now look at the first one. Whose molecules whose mirror image is non-superimposable over them are called chiral. Which of the following molecules are chiral in nature? 22. Who will tell me answer for 22? Who will tell me the answer for 22? 2-bromobutane, please write. Does it have a chiral molecule? Is it chiral molecule? Can you tell me? Hari Raghav, can you tell me if this molecule is chiral? This is 2-bromobutane. Does it have a carbon atom which is asymmetric? Hari Raghav?
Ma'am, I think no. Ma'am.
See, if you look at the first carbon atom, carbon atom number 1, it is attached to 3 hydrogens. So this cannot be asymmetric. Look at third, it cannot be because it is attached to 2 hydrogens. Look at 4, it is attached to 3 hydrogens. So look at this second carbon atom, right? What are the groups around it? On one side, it is hydrogen. On the other side, it is Br, right? On one side, it is CH2, CH3. On this side, what does it have? CH, right? So this carbon here is asymmetric. So answer is 1.
Ma'am, why can't be 2, ma'am? Second option.
1-bromobutane. Now let me write here 1-bromobutane. So 1-bromobutane is CH2Br, CH2, CH2, CH3. right? Now, in this case, you see this carbon, let us start from the right side. This carbon is attached to 3 hydrogens. So it cannot be attached to 4 different, 3 are hydrogen only. 2 are hydrogen. Here also 2 are hydrogen. Look at the first carbon atom. First carbon atom, what are the groups around it? It is hydrogen, hydrogen, Br, and this whole thing, CH2, CH2, CH3. So this is 1, this is 2, this is 3, this is 4. Now hydrogen and hydrogen, the moment you have 2 hydrogens, they are same group, so it cannot be asymmetric. On each carbon atom, you look like that. So wherever there is a carbon which has 4 different groups, then only it becomes asymmetric. So first one only has a 2-bromopropane. What is 2-bromopropane? This is 2-bromopropane, right? So on the first carbon atom, what do you have? 3 hydrogens, so it cannot be. Second carbon, there are 2 methyl groups on it, so it cannot be. Like that, one by one, you have to rule out. So here, luckily, you found the first one itself had asymmetric. So then reaction of CH2Br with aqueous sodium hydroxide follows SN1, SN2, any of the above depending on temperature or Sedgwick's rule. Now here, you know, SN1 and SN2, how will you decide? Based on the intermediate. Where will the intermediate, will it form a stable intermediate? Will this bond break easily, and when it breaks, will it form a stable intermediate? So here C6H5CH2 benzyl carbocation is also like tertiary carbocation, stabilizes by the plus I effect of 3 alkyl groups. Similarly, this one also stabilizes very easily, and so it will undergo SN1 reaction. Wherever the carbocation is stable, it undergoes SN1 reaction. Sai Kalyan, anything that you can think here? I like your insight.
Nothing.
Yes, correct? Okay. So we have almost done everything. So any other doubts or questions you have, you can put it, your learning room team has told me that if you post any doubt there is a place where you can post your doubts, they will send the doubts to me, and then I will reply and you will get my reply. So as soon as I get the doubt, I will clear. So please revise everything. Now see you after 2 weeks. So we have done 2 topics, our haloalkanes and haloarenes, and the other one is solutions. So both the topics you should be completely thorough. Okay. So which will undergo SN1, which will undergo SN2, and which will form. Today we did a very good question, and I'm so happy at the way Sai Kalyan pointed out. So I was ignoring that important point. So racemization will only happen if you're starting the compound, the product that you are getting is optically has a chiral carbon. If the product doesn't have a chiral carbon, there is no question of racemization. So you should see first of all that your product, your starting compound should have a chiral carbon. Then once you verify that it has a chiral carbon, then you should see that it should be able to undergo a SN1 reaction. So if it undergoes a SN1 reaction and it is chiral, then it will undergo racemization. If it is optically active compound and it is undergoing SN2 reaction, then the product will be optically inverted. There will be optical inversion. Okay. So just learn all this part of your textbook. Please read, understand, look at all the examples in the textbook, then you'll be able to do that. So see you children. Thank you very much for your patient listening. See you all.
Thank you, ma'am.
Okay.
Thank you, ma'am.
All the best for the test.